Today we looked at combining like terms, and our directions for our homework said to determine whether the following terms are like terms, write yes or no. And in order for them to be like terms, they need to have the same variable following the coefficient. Doesn't really matter what the numerical number is in front of that variable, because when we get into combining like terms down further on the worksheet, we'll be combining those numerical values, adding and subtracting the integer values to simplify the expressions. But up here, all we have to do is pay attention to what variable is attached to the coefficient. So on number 1, we have 6x and 8y. X is not the same as y. No matter how many times you try to think it is, it just doesn't match. So since x and y are different variables, we do not have like terms that can be combined, so we would say no. Let's look at number 7. Number 7, we have 3x and negative x. In this example, both values that are given, or both terms that are given, have a x variable, so we do have like terms. Let's look at one more just to make sure we don't get confused. Number 8, 11w squared y, and our second term is 4wy. Well, now both of these terms have have a number coefficient, have a w, and have a y. But we need to be careful to remember that w squared is different from w, which has an implied power of 1. And so in this case, these are not like terms. They cannot be combined in any way. Now let's look at some examples of simplifying expressions. We have 5x minus 8x. And again, we're getting back into adding and subtracting integers, so you need to be careful with your integer rules. We do have like terms. Both of those coefficients have a variable x on them. And so we can simply find the difference between the two, keep the sign of the larger absolute value number. So 5 minus 8, the difference between the two is 3. The larger absolute value number had a negative sign on it, so we're going to keep the negative. And then we were combining an x term, so we will keep the x on our solution. So 5x minus 8x is negative 3x. Let's look at example number 11. 4 plus 6y minus 1. Well, here we can combine like terms, but we can't do anything with the 6y because our 4 doesn't have a y and our 1 doesn't have a y. So I'm going to use my commutative property to rewrite this expression. 4 minus 1 plus 6y. Because that puts my two integers right next to each other, so I can go ahead and simplify this expression down just a little bit. 4 minus 1 is 3 plus 6y. And now, since we're simplifying and we learned how to do factoring yesterday, I bet you could even go ahead and factor this down one more step, couldn't you? Let's find a GCF between these two terms. The GCF, well, it would have to be at least 3 or less, and since 3 is my greatest common factor, 3 would go into 3, and 3 would also go into 6, so I could pull out a 3, and that would leave me with 1 plus 6 divided by 3 is 2, so 2y. And now we've gotten that problem as simple as it can possibly go. Let's look at one more. How about number 15? Number 15 says 5w squared minus 3x plus 8w squared minus 1. Again, I think it's a good idea to go ahead and use that commutative property rule, but first I'm going to rewrite this problem with some additive inverse property rules. So 5w squared plus negative 3w plus 8w squared plus negative 1. And the really big reason why I did it this way is because I want to remember to move those negative values with the term that's attached to them. So now I can use my commutative property of addition and take my 5w squared plus my 8w squared and put those at the front of my expression plus negative 3x. I don't know why I changed that to w. Plus negative 1. Now we can go back through and see, is there anything more that can be simplified? Well, we have like terms here on these two terms in our expression. Both of them have the variable w squared, and so we can combine them by adding the two terms together. 5 plus 8 is 13w squared plus negative 3x plus negative 1. And I don't see anything that can factor out in this example, so that would be as simple as we could get this problem to go. Hopefully that gives you a good start on combining like terms. If you have any questions, we'll answer them tomorrow in class.